Pluto, once classified as the 9th planet in our solar system, has long been the subject of intrigue, particularly following its reclassification as a dwarf planet. This shift in status sparked much debate among astronomers and the general public alike. Recently, two prominent astrophysicists, Neil deGrasse Tyson and Mayo Eku, added fuel to the fire with a startling assertion: Pluto could be on a collision course with Neptune. But could this actually happen, and what would be the consequences of such an event? Let's take a deeper dive into the complex and fascinating world of Pluto's orbit. Pluto's orbit is far from ordinary. Unlike the nearly circular orbits of most planets, Pluto's orbit is highly elliptical and tilted at an angle. This means that for a portion of its 248-year orbit, Pluto actually gets closer to the Sun than Neptune. This unusual configuration raises a critical question: if Pluto and Neptune's orbits overlap at certain points, why hasn't there been a catastrophic collision? The answer lies in the delicate and complex mechanics of their orbital dance. Although Pluto and Neptune's orbits come dangerously close to intersecting, they are locked in a gravitational ballet that prevents them from colliding. This orbital resonance is a remarkable phenomenon. The two bodies, despite their proximity, are in a synchronized relationship where for every 2 orbits Pluto completes around the Sun, Neptune completes 3. This resonance ensures that when Pluto gets near Neptune's orbit, the two never occupy the same point in space at the same time. But the stability of this situation is not a random occurrence. A concept known as azimuthal libration comes into play, which involves the interplay of the gravitational forces that keep Pluto's orbit stable. This means that Pluto's path is continually adjusting to avoid any risk of collision with Neptune, even as both objects orbit the Sun in an eccentric manner. Another critical factor is latitude vibration, a phenomenon that causes Pluto to move slightly up and down in relation to the plane of the solar system, further reducing the likelihood of a collision. Astrophysicists have long studied Pluto's orbit and have concluded that it is indeed chaotic, yet stable over incredibly long periods. Early numerical simulations from the late 1980s indicated that while Pluto's orbit may appear erratic, it remains predictable over the course of millions of years. The gravitational influences of nearby planets, particularly Jupiter and Saturn, also play a role in preventing Pluto's orbit from spiraling out of control. Their massive size and powerful gravitational fields act as stabilizing forces, keeping Pluto on a relatively steady path. Despite these stabilizing factors, the future of Pluto's orbit is not set in stone. Some astrophysicists argue that while Pluto's orbit appears stable now, small changes in its path could lead to significant alterations over millions of years. The gravitational interactions with Neptune and other celestial bodies could slowly shift Pluto's orbit, potentially bringing it into a more dangerous territory. This unpredictability adds an element of mystery to our understanding of Pluto's future. The recent statements by Tyson and Mayo Eku reflect a broader fascination with the evolving nature of the solar system. The idea of Pluto and Neptune colliding, though improbable in the near future, serves as a reminder of how much we still have to learn about the cosmos. The complexity of gravitational interactions, orbital mechanics, and the long-term dynamics of celestial bodies ensures that space remains a realm of endless discovery. Tyson's comments on Pluto's reclassification and Mayo Eku's concerns about its potential collision with Neptune highlight just how dynamic and unpredictable space truly is. Even though the chance of a catastrophic event between Pluto and Neptune seems low at present, the possibility remains, however small, because of the chaotic nature of Pluto's orbit. It's this very unpredictability that keeps astronomers on their toes, constantly refining models and hypotheses as they observe the ever-changing behavior of the universe. In the end, Pluto's eccentric orbit is a perfect example of the complexities of our solar system. It serves as a reminder that, while we've made incredible strides in understanding space, The universe is full of surprises, and some mysteries may never be fully solved. So, while Pluto may not be headed for a collision with Neptune anytime soon, the path it takes will continue to captivate our imaginations for years to come.